Welcome to this ByVal tutorial. In this fairly short video we're going to explain a bit about what ByRef and ByVal means in Excel VBA. So the video is really all about passing arguments in VBA. We'll start with a quick description of passing values between procedures, using a very generic example to demonstrate the principles. And while we're doing that we'll explain what ByRef and ByVal mean and how you can use those keywords to affect what happens to values as they're passed into different procedures. Once we've covered the basic theory, we'll have the second half of the video looking at some practical examples to help you understand where you can use these keywords and how you can apply these techniques in the real world. So let's get started. Let's start with a really simple example, just to demonstrate the principles of ByRef and ByVal. You won't need any data to begin with, so I've just started a brand new blank Excel workbook, and I'm going to head straight to the Developer tab and then into the Visual Basic Editor. Once there, I'm going to insert a new module, and I'm not going to bother renaming it. Module 1's fine just for this simple first example. In this module, we're going to write two separate subroutines, and we need two subroutines because ByRef and ByVal are all about controlling what happens when you pass information between subroutines. So the first simple example, we're going to create a subroutine which allows us to assign a number to a variable. And then we're going to pass that number into a second subroutine, which is going to do something to that number. So it's probably just going to increase its value by 1. And then right at the end, we're going to investigate what the final value of that original variable is. So let's start with our first subroutine. We'll call something like set a number, or choose a number, or something along those lines. And we're going to declare a simple variable, which I'm going to call, I don't know, let's say original number. And we're going to set its data type. Let's call it original num, in fact, for short, and we'll call it, or we'll give it a data type of integer. So we have to assign a whole number to that variable. We can assign a value to it by saying original num equals, and I don't know, pick an arbitrary value, let's go for 5. And then the next step is to pass that number into another subroutine. Before I do that, in fact, I'm going to write a debug.print statement just so that we can clearly see what the value of this number is as we proceed through our procedures. So let's have debug.print original number, sorry, let me spell that properly, I'll try again, original number equals, and then we'll just concatenate the value of original number. So if you remember from earlier videos, you can press Ctrl and space to display this IntelliSense list, just to help you speed up entering text. Okay, so we need to create another subroutine now that we can pass that original number into. Let's call this second subroutine something along the lines of increase a number. And the really important thing about this subroutine is it must have a parameter into which we can pass a value. So let's open a set of parentheses there, and I'll call the parameter something like number to increase. And then we must assign a data type to that as well, so let's say as integer to make sure it matches our original variable. And then inside this subroutine, all we're going to do is take number to increase and make it equal to itself, number to increase, plus 1. And then what I'd like to do is print out the value of that parameter. So let's say debug.print, and we'll say number to increase equals, and then concatenate that with the number to increase. Okay, once we've created this subroutine, then we can write a call to that subroutine in the original one. So let's head back up to subroutine number 1, and we can write a call to this simply by saying increase a number. And if I type in a space after that, we'll see a lovely little tooltip pops up showing me I've got to pass a value into it. So the value I'm going to pass in is going to be my original number. So let's say original number, or original num in fact. And then the final step is to print out the value of original number. So let's copy and paste the debug.print statement from before the call to the procedure, and then paste it in again immediately below. One last little note, I've probably mentioned this in previous videos, an alternative way to call a second subroutine is to actually write the literal word call in front of the procedure's name. If you do that, the only thing that becomes different is that you must wrap up your argument list in a set of parentheses. So you can see that currently there's a syntax error here, the line of text has gone red. If I wrapped up the entire argument list in a set of parentheses, suddenly that's okay. For this example, I'm going to miss out the call keyword, and I'm going to miss out the parentheses as well. So if you do use call, you must use the parentheses. If you don't use call, then you shouldn't use parentheses. So that's the entire thing set up. All we need to do now is run the procedures and see what the output is, and in order to see that we'll need to display the immediate window. So you can do that either by pressing Ctrl and G on the keyboard, or head to the view menu and choose immediate window. And then, once we've done that, let's begin stepping through the original procedure, set a number. So I've clicked somewhere inside the subroutine. Now if I start by pressing the F8 key, it will begin stepping through. So each time I reach a statement that says debug.print, it's going to write out that piece of information into the immediate window. So I'm going to execute that instruction. Original number is 5. That's not very surprising at all. And then I'm going to pass the original number into the increase a number subroutine. So when I press F8, it will launch that subroutine and it will pass the value 5 into that. And then it's going to increase the number we've passed in, and of course it will then print out that the number to increase is 6. And then when I end this subroutine, it returns to the final line, or the line immediately following the call to this procedure in the original procedure. So the question is, without cheating, what would you predict the value of original number would be? It could be one of two different things here. It could legitimately be 5 or it could be 6, and unless you know how ByRef and ByVal works, you've got no possible way to guess correctly. So if I press F8, we're going to find that the value is actually the number 6. So original number has also had its value increased by the call to the increase in number subroutine. So this video is essentially explaining why that happens. I'm just going to press F8 one more time to end this subroutine and see if we can explain why. The key to working out what's going on here is in understanding how VBA variable values are stored in memory. So when you declare a variable like we have here called original num, a unit of memory gets allocated to that variable, and you can reference that memory space by referring to your variable name in your VBA code. Now when that piece of information gets passed into another procedure, that space in memory can be passed in a couple of different ways. It can be passed by ref or by val. In VBA, the default is always by ref, so this won't make any difference to the way our procedures work, but if you wanted to be explicit, you could actually write the word ByRef in front of your parameter names in your subroutine declarations. So if I enter ByRef here, and then I'll just clear out the contents of the immediate window just to demonstrate what's going on, and then click back into the original subroutine, set a number, and step through again. So it won't be any surprise that original number is indeed 5, and then we can pass that into the increase in number subroutine, which will increase its value, and of course that will increment to 6. And then again, when we return to the original calling procedure, the value of the original variable will have retained the change we made. It will be 6 as well. So that's what happens when you pass information by ref. So what's actually going on there? Here's a really basic diagram to try to help understand what's going on when you pass information by ref. Imagine this grid here as a very simplified version of the memory of your computer. So when you declare a variable in VBA, as we have here, original num, you get allocated a space in that memory to store the value. So we can assign a value to it, as we've done here. The number 5 gets stored in that memory space, and then we can refer back to that memory space later on to retrieve its value, as we've done in this debug.print statement. And then we've got a call here to a separate procedure, and we've said to pass that information by ref. That's how the parameter has been declared, by ref. So when information is passed by ref, it's not the value stored in the memory space that gets passed to this second procedure. What gets passed instead is a reference to the memory address location. So imagine, in simplified terms, that this memory space was called G2. That's the cell that it's sitting in our Excel worksheet. This is like saying pass into the increase in number subroutine a reference to cell G2. So the subroutine doesn't technically know that it's the number 5. All it knows is to look into memory space G2 to find the piece of information that's in it. So we can refer to that memory space, and we can then modify the value in that memory space as well. So it stands to reason that if we modify the value in that memory space in this subroutine, when we're calling it number to increase, it must also affect the value of the original variable, where the variable is referred to, or this memory space is referred to, with the words original num. So it's effectively the same as having two different names for the exact same space in memory, original num and number to increase. Which hopefully explains why, when we return back to the final line of the original subroutine, if that's changed to 6 in the increase in number subroutine, it must also have changed to 6 in the original subroutine as well. Now that you know what ByRef does, you can probably already predict what the effects of ByVal are. So let's give it a quick try. Let's change ByRef to ByVal, and then let's clear out the contents of the immediate window again, and we'll step through from the original procedure, set a number. So again, the first few parts won't be too surprising. The original number is 5 because that's what we've assigned to it, and then we increase the value of that number in the second subroutine, and that becomes 6. And as you can probably predict at this stage, if we're passing information by val rather than by ref, the final step means that the original number hasn't been changed by the call to the second subroutine. Now again, a basic diagram might help to explain what's going on when information is passed by val. So again, we have the original subroutine with a variable declared, which means we're allocated a space in memory, and we assign a value to that. And then the piece of information is passed this time to a second subroutine by val rather than by ref. So rather than this variable pointing to the same space in memory, what effectively happens is that a copy of that memory is created and a separate memory space is allocated to the copy. It doesn't really matter which one we choose. I've gone for I7 arbitrarily, and that space in memory is of course completely different to the one that we originally assigned a value to. So the number to increase parameter this time points to a separate space in memory, which means that if we decide to modify that value from 5 to 6, say, it means that the original value hasn't been changed at all. So when we go back to the original subroutine, original number still has its original value. Now I think that understanding the difference between what ByRef and ByVal do is reasonably straightforward. But what often happens on a training course at this point is that people will ask, well, where am I going to find that useful? What can I do with this? And I think that might be slightly the wrong way to think about how ByRef and ByVal work. It's not so much that they're techniques you can use to do something particularly impressive or clever. These are just keywords, really, that allow you that bit more flexibility and control over the information in your procedures. So let's show you maybe a couple of other slightly more practical examples of where ByRef and ByVal will come in, or at least help you to think about how information gets passed between your procedures. Let's start with another new module. So let's insert a new module, and again I'm not going to bother renaming it. What we'll do in here is write a set of 3 different procedures that are going to calculate various bits of information about circles. Let's start by declaring a subroutine that allows us to set the radius of a circle for which we want to find some extra information about. So we're going to say sub set radius, and then in there we'll declare a simple variable. I'm going to call it r as double, and then we can assign a value to that just as we did earlier on with our original number variable. I'm going to say r equals 5. And what I'd like to be able to do at this point then is print out several bits of information about the circle. So let's start by saying debug.print radius equals, and then concatenate the value of r to that. And then I'd like to be able to call on 2 separate functions to calculate both the area and the circumference of the circle. Let's declare a function then that will calculate the circle's area. So I'm going to create a function called area, and I'll have a single parameter for this function which will be called radius as double, and the function is going to return a double as well. Now thinking back to my secondary school mathematics, the area of a circle is equal to pi multiplied by the radius squared. So let's start by saying radius equals radius to the power 2. I know this isn't necessarily the most efficient way. This is a slightly contrived example just to demonstrate the principle of ByRef and ByVal again, of course. I don't need to do it this exact way, but I've squared the radius, so all I need to do then is multiply it by pi to return the area. So the next line I'm going to say area equals worksheet function dot pi, quick simple way to get that value from Excel's worksheet function, and then multiply that by my new radius, or my radius squared. What I can then do is head back to my original subroutine and say debug.print. I could try to do that. There we go, debug.print area equals, and then concatenate that with a call to the area function. So I'm going to say area, and because I'm calling a function and returning its value, I'll need to wrap up its arguments in parentheses. So if I open a set of parentheses, I'm going to pass the value of r to that. Okay. Next we'll create the function that returns the circle's circumference. So if we declare another function, which I'm going to simply call circumference, probably should have picked a shorter name, but there we go, circumference, and then I'm going to say once again radius as double, and then that's going to return a double as well. And again, thinking back to high school maths, the circumference of a circle is 2 multiplied by pi multiplied by the radius. So to make that work, we can simply say circumference equals 2 multiplied by worksheet function dot pi multiplied by radius. That's a nice simple one. Okay, once again we can head back to the original procedure where we're setting the radius, and I can say once again debug.print, and we can say circumference equals, and then concatenate that with a call to my circumference function, and once again I'll need to open some parentheses and pass in the value of r. So let's give the entire thing a quick test. I'm going to start by clearing the contents of the immediate window, and then I'm going to click back into the original set radius subroutine and then run the entire thing either by clicking the green triangle or pressing F5, and we'll get a set of answers in the immediate window. Now in this case the circumference is being calculated incorrectly, and the reason for that is because of the way we passed the information into the area function originally. So if I stepped through the subroutine this time rather than running the entire thing from scratch, we'll see that of course we print out the original radius of 5 and then we pass the value of 5 into the area function. But then we make a modification to the value we passed in. So by default information is passed to procedures in VBA ByRef. So modifying the radius here also affects the original value of r in the original subroutine, and in fact just hovering the mouse over it immediately here you can see that it's equal to 25 now. So I can return the correct radius. That actually does work. The radius, the area calculation is correct. But when I pass a value to the circumference function, it's being passed in as the value 25 rather than the original 5. So in this case, we're calculating the circumference of a circle significantly larger than the one we think. So the solution, and it's a simple solution of course, is to pass the value to the area function ByVal rather than ByRef. We don't need to do the same thing for the circumference function for two reasons. One, we're not modifying the value of the radius inside the function, and two, we're not subsequently calling any other functions afterwards anyway, so we're never using the value of the radius again after its final call to the circumference function. And it would have been perfectly possible here, of course, to rewrite the area function in such a way that the radius wasn't affected. I could have simply said area equals worksheet function multiplied by worksheet function.pi multiplied by radius to the power 2, and that would have had no effect on the final output. It's simply because, in a very contrived way, just to demonstrate the principle once again, we're making a modification to the value passed into another procedure. So, having made that change, I'm going to clear some of the immediate window, so I want to leave the original set of values in there. So the circumference originally came out as 157, and then if I run the entire thing again from scratch, I'll end up with the correct circumference of 31, which is somewhat different to what we originally saw. Okay, for the last example we're going to do in this video, we're going to write a procedure that loops through a range of cells containing numbers. In this case they represent their length in minutes of some films. I think these are the top 5 highest grossing films ever or something. Shouldn't be The Force Awakens be in there somewhere? Anyway, it doesn't really matter. What we've got here is a list of numbers representing minutes, and we want to convert those into hours and minutes. And we're going to do that by using an array. We're going to loop through the values stored in the array and then calculate the values of hours and minutes using a function. So we're going to need to pass each of these values into a separate procedure. So let's start by heading back to the Visual Basic editor, and I'm going to begin another new module. So I'm going to insert a new module, and then we'll start by writing the basic main routine. So let's have a subroutine that's called, let's convert minutes to hours. The most efficient way to process this list of values in an array is to start by declaring an empty array. I'm going to call mine mins, and then we can simply assign a range of cells to it. I've covered this technique in a lot more detail in a previous video on arrays, so it's part of this this overall tutorial. So I won't bother going into too much detail here. I don't want to repeat myself. But what we're going to do next is we're going to assign a range of cells to the mins array by saying mins equals, and I'm going to say range, and then the top cell in the list was B2, and I can find the bottom cell in the list by saying something along the lines of range B1 dot end XL down, a technique we've used many times in this series. And then we can simply loop over the contents of that array by saying, I'll need another variable in order to do that, so I'll need a counter. Let's say dim I as integer, and then I can say for I equals, I want to use the lower bound number of the array, so that's L bound mins, 1. So I'm looking in the first dimension of the array for the lowest bound element, to U bound. And again we're going to say mins, 1. So looking in, again, the first dimension of the array for the upper bound element, so the highest number in there. Then I'm going to say next I, and inside this loop, basically what I would like to do is pass in the value of the mins array that I'm looking at into a separate function. So let's create our function next. I'm going to declare a new function, which I'm going to call simply, let's say, mins2hours. And I need to declare a parameter for this function, which I'm simply going to call m as integer. So this represents the value of minutes that we pass into it. So to return the value, we're going to say mins2hours equals, and there's a couple of different parts of this calculation. First of all, to calculate the whole number of hours that the film lasts for, I'm going to say int, and then I'm going to just divide m by 60. And that will return just the whole number portion of the result of that calculation. And then I'd like to concatenate to the end of that the letter h, as well as a space, and then I want to concatenate onto that the number of remaining minutes that don't fit into a whole hour. So the way that I'm going to achieve that is I'm going to open a new set of parentheses, and I'm going to say m mod 60. So the modulus operator returns the remainder of dividing one number by another. So if I were to then close a parentheses and then finally concatenate the letter m to the end of that, we should end up with a result of hours and minutes for any whole number that we pass into the function. The next step is to pass the correct number into the function each time we process this loop, this for next loop. So just to demonstrate what we're going to be doing here, I'm going to view the locals window. This should hopefully help to explain what's about to happen. If I then go back to my subconvert minutes to hours and begin stepping through this, just to demonstrate what happens when you assign a value or assign a range of cells to an empty array. So we have this mins array in the locals window down here. As soon as I hit F8 here, it generates an array, populates this array with a two-dimensional array. So you can see that I've got 1 to 5 and 1 to 1, so I've effectively got 5 rows and 1 column in this array. So if I want to refer to a value of the array, I've always got to refer to it with the element of both dimensions, so 1, 1 or 2, 1, etc. I can't just say a single element. So to make that work, if I just reset this one, I would like to say mins, open some parentheses, I, 1. So the first time the loop goes round, that will populate the value of element 1, 1, and then the second time it will be 2, 1, 3, 1, etc. I'm going to make this equal to the result of mins2hours, and the value that I'm going to pass into this is again mins I, 1. If I close all the correct parentheses, that will pass the correct value to that function. Now just before we test this, there's one last thing I forgot to do, which was to declare the return type of the function. It's not technically necessary, it will work anyway. It's just better if you can be explicit about every data type you're using. So in this case, the function is going to return a string. And then, still with the locals window displayed so we can see what's going on here, I'm going to attempt to step through this procedure using the F8 key. So I click into the convert minutes to hours subroutine and hit the F8 key. It will immediately fail. And it fails with a descriptor with a message that includes the word ByRef. So ByRef arguments type mismatch. So once again, we're in a situation where, to make this work correctly, we're not going to use the default ByRef technique for passing information between procedures. I'm going to click OK and then reset the procedure. I'm instead going to say ByVal. Having done that, if I click back into the convert minutes to hours subroutine and then again press the F8 key, we'll successfully be able to step through the procedure now. So let's continue going. If I populate the mins array first of all, so we'll see that the values stored in that array are the values of runtime in minutes, so 161 currently for the first one, which corresponds to the first film in the list. And if I use F8 to pass that value into my function, we will see that when it comes back, mins2hours returns 2 hours 41 minutes. So when the function ends and we return back to the original procedure, if I look into the mins array, we'll find that where it was previously 161 is now 2h41m. And then we will simply carry on going through each of the other values stored in the array until they've all been processed. So at that point I'm just going to press F5. The final step to this and this pair of procedures, currently all that just happens in memory. The results don't actually get spit out into the cells at the end. So just to complete the entire procedure, let's head back to the VBA editor, and we need to add a single line of code in at the end just to return the results of the array into the correct number of cells. So to do that, what we're going to do is say range C2, and a neat little technique here is to resize this range to match the size of the array. So I'm going to say range C2.resize. The number of rows I would like this range to hold is going to be equal to the upper bound element of the first dimension of the mins array. So ubound mins, 1, and then the column size is going to be 1, and then I can simply make that equal to the entire mins array. So essentially it's just doing the reverse of what we did previously to populate the array. So having done all that, I'm just going to, rather than step through, I'm just going to run the entire pair of procedures and have a look back into Excel and see that all those values have been spit out into the correct cells. So that's the end of our basic video on ByRef and ByVal in Excel VBA. We've gone from the basics of demonstrating what the idea behind ByRef and ByVal actually is and what those keywords actually do. We went through an example that's slightly more practical, although agreed slightly contrived, to demonstrate why you need to be careful about your assumptions when you pass information to different procedures. And then we wrapped up with a slightly more practical example where it was essential to pass information by val rather than by ref, otherwise the entire thing wouldn't work. So hopefully you've got a better understanding of how that works. Thanks for watching, see you next time. If you like what you've seen here, why not head over to the ByRef website, where you can find loads more free resources, including these videos, some written blogs and tutorials, and even some exercises that you can download to practice your skills. Thanks for watching, see you next time.